So here we are on 8.7 comparing data sets. So just remember that dispersion is how spread out our data is. Central tendency is the location or data point in the middle. Or tells us something about that data. So here we have 4 histograms. Each histogram above shows the bowling scores for the last 25 games played by each person. Choose 2 of the people to join your bowling team. And which ones would you pick, and how would you use the histograms and statistics to support your decision and explain your reasoning. So if you want to pause this video here, try and come up with what you think, which one you might like, or which 2 on your bowling team you would pick. So if I'm looking at this data, I'm seeing that like person A has a mean of 118. That's pretty low. Person B has a mean of 131. Their range is pretty solid. They do a good job each time. Mean of 133 for person C, even though they get some really low scores. And then person D averages 116, but they bowled either 290 or 300 one time, so that they're pretty good. I would say if I was choosing 2 people, I would choose at least person B, because of how consistent they are. They're bowling in that middle range. And then maybe I would also choose maybe person C. They have a good chance. There's quite a few games that they bowl pretty high, so maybe you get lucky a few of the times to get some good scores. On example 2 here, we're looking at a couple of dot plots, and we're looking at the ages of 30 to 39, the marathon finish time, and then ages 40 to 49 and their finish times. So which age group tends to take longer to run a marathon? Well, if we're looking kind of here, the main part of our data is probably sitting right in there. That's probably our average is probably somewhere right here. If I'm thinking there's a few here, and we could kind of find the median or the middle number, or the average of this, but we're just trying to interpret the data just based on looks. And then for 40 to 49, we see that there are some low numbers here, but our means probably, if you take maybe these and these are probably 1 quartile, our medians probably, or our middle number or mean might be right there. So I'm going to say 40 to 49 take longer. And I'm just going to say because the data is more spread out. That we think that's where the middle is. Which age group has more variable finish times? And I'm going to say that the 40 to 49 has more variability or dispersion that helps lengthen that data out. So here we are, we're looking at some of that data with actual numbers now. So the 30 to 39 averages 294.5 minutes. That standard deviation we see that determines our spread of our data is low. And the middle number is 288.5. It's close to that 294 number. And we can see that interquartile range, quartile 1, quartile 2. We can see that interquartile range is shifted. It's more in, while the 40 to 49 is 92. And says, how do you think the finish times for the 20 to 29 range will compare with these 2 distributions? So if we're thinking about 20 to 29, do we linearly get worse over time is kind of the question. So maybe the 20 to 29, the mean might be maybe like 270 minutes or something like that. And the standard deviation might be lower. It might be 30 minutes in between each time. Our median should also be a little bit lower, maybe around 275, or maybe even lower. Our interquartile range, probably something smaller, maybe around 45 minutes, and so on, kind of something like that. So on example number 3, it says determine the best measure of central tendency and measure of variability to use based on the shape of the distribution, then determine which set has the greatest measure of center as well as the greatest measure of variability. So part A, or on letter A, if we're looking at example 3, I can kind of see this data has like this trend here and this trend here. We're probably looking at the mean probably. If we don't really have any outliers, means our best estimate. The greatest measure of center here, well, here my center points are -8 and -10, so the greatest measure would be -8. The best measure of dispersion, the greatest measure of dispersion, well, I can see that most of my data here lies out here, while a lot less of my data. So I'm going to say the greatest measure of dispersion is 1A. On example number 4, we have the same thing. On example number 4, we can see that our data is kind of grouped together. One's really low, one's kind of clumped. So probably our mean is probably still our best bet. We don't really have any outliers. Our greatest measure of central tendency here, we're probably sitting right at 19.5 or 20. Here our mean is like up at 30, so our greatest measure of center here is probably 30. And our dispersion here is probably 2A. This is really dispersed over time. This is really a kind of like a hump of data that's all together. Here we have 2 box and whisker plots. I can't really see any outliers. They normally outline outliers with dots. So we're going to say the mean's probably the best measure of central tendency, or maybe even the median on some of these, because it's a little bit more accurate, and we can kind of determine where the median is with that middle line. Our greatest measure of center here, well, this one sits right about at 500. This one sits about at 700. So we're going to put 700 there. Cross that one out again. Our greatest measure of dispersion, this one goes from about 700 to 200, and this one goes from 500 to 1,100. So this has a dispersion of 600, this has a dispersion of 500 for that interquartile range, or from the whole range of our data. So maybe 5A has a greater measure of dispersion. Our last one here is that we have looking at 2 kind of like word problems. So we have a political podcast that has mostly reviews that either love or hate. So if we have like a dot plot, a bunch of people hate it over here, not too many people like it, but then a lot more people love it. So the best measure of central tendency here is probably the median or mean, and then that's probably going to be somewhere in the middle of our data. And then here for cooking that neither hate or love, I mean, there's probably some here, but most of our data is probably going to lie in the middle. So that would be kind of our mean. And then, so our greatest measure of dispersion here is probably going to be the podcast or the political podcast, just because either people love it or hate it, so it's going to cause a bigger dispersion.